SOLIDWORKS Plastics 2021 gives you insights into new injection molding processes for your designs, as well as continuing to simplify and streamline the setup process. A new injection molding process is available in Plastics 2021 to accommodate multiple material overmolding. This manufacturing process is perfect for parts like this that require a soft protective covering molded over the rigid plastic. You can now also fully define your analysis before any meshing is required. This starts with selecting materials for each injection process. SOLIDWORKS Plastics 2021 has added over 300 new materials from global manufacturers. For the first injection, one of the new ABS materials from BASF will be used for the main body. The second injection process will use another new material, a thermoplastic, for the soft protective cover selected from the recently used list. Once the material for each injection process has been specified, you simply need to apply the material to its associated domain, in this case the ABS to the part body and the TPE to the overmold geometry. SOLIDWORKS Plastics makes it easy to define other critical elements in your plastics analysis as well. For instance, you can define cooling channels without the need to physically model the mold. SOLIDWORKS Plastics 2021 significantly improves your simulation results by creating more realistic baffles and bubblers within these virtual cooling channels. All you need to worry about are the specifications for each type, which include parameters like the OD, height, and the thickness of the blade in the baffle channel and ID tube in the bubbler channel. You will see how these new changes impact the mesh shortly. Like the cooling channels, you can define a runner system and a virtual mold, allowing you to analyze and look at multiple scenarios for your injection process before investing time and energy into designing and modeling the complex components of the mold itself. All of these domains, like the part geometry, can now have their materials applied to them prior to any meshing taking place, allowing you to fully specify the components in your plastic injection analysis. Other critical mold design elements, such as the injection locations, can also be defined directly on the 3D model without the need for meshing any geometry. By referencing the geometry itself instead of the mesh, it saves time setting up different design scenarios, as well as automatically updating when the 3D model itself changes. All of these boundary conditions in the plastic study can be defined geometrically this way. This includes other design elements such as the cooling channel inputs and outputs, as well as things like the clamp force direction. The entire plastics analysis has been defined geometrically and virtually. This makes the file on disk smaller, portable, and more adaptive to changes. Eventually, when you do mesh the model in preparation for the final simulation, you will immediately see the benefit of those improved baffles and bubblers defined earlier. They are now fully meshed and modeled appropriately, giving you more accurate simulation cooling results without the need to fully model the cooling channels and the physical components that make up those special inserts. By defining the entire simulation study on the 3D model in virtual domains, it has enabled a more dynamic workflow where you can look at and evaluate different scenarios in your design before any of the heavy lifting is done. The results themselves, which include the new multi-material overmold injection process, are now more accurate when considering cooling, giving you confidence in your injection molding process before you even start designing or investing time and money into the mold itself.